Okay, we are starting this 2009 paper. Good morning, everybody. This is the Canada Rocky Mountains that we visited like a couple of times there. Just refreshing your brain. So 2019 we are doing. And there is this one question that in question number 10 that we are doing the implemented. That's why I didn't do these questions during this theory unit 14. So we're going to come here and we're going to get this practice. That is one of the reason I choose this 2009 paper for you. Okay, that's again 60 MCQ question. Let's see answers. Question number 1, answer 4. 2, answer 3. 3, answer 3. 4, answer 2. 5, answer 4. 6, answer 2. 7, answer 1. 8, answer 1. 9, answer 3. 10, answer 3. 11, 5. 12, 5. 13, 1, 14, 4, 15, 2, 16, 5, 17, 1, 18, 5, 19, 3, 20, 5, 21, 4, 22, 2, 23, 2, 24, 3, 25, 1, 26, 5, 27, 4, 28, answer all. 28, answer all. 29, 2, 30, 4, 31, 2, 32, 4, 33, 4, 34, 5, 36, 3, 33, answer 4, 34, answer 5, 35, answer 2, 36, answer 5, 37, 4, 38, 2, 39, 3, 40, 1, 41, 4, 42, 1, 43, 5, 44, 4, 45, 2, 46, 4, 47, 2, 48, 5, 49, 1, 50, 1, 51, 2, 52, 3, 53, 4, 55 again, all, 55 all, sorry, 54 all, 53 answer 4, 54 answer all, 55 answer 3, 56 answer 4, 57 3, 58 there are 2 answers, 1 and 4, 59 answer 3, 60 answer 5. Let's discuss questions and see what is your marks, because some may changing with, you know, some sort of like all the stuff we are just skipping. Okay, in room temperature, there are 11 gases. How you remember very easily, there are 6 inert gases that you can memorize easily. Other than that, hydrogen, nitrogen, oxygen, fluorine, and chlorine. Hydrogen, nitrogen, oxygen, fluorine, and chlorine. Just tell me if somebody is trying to join, because I'm looking at the screen. I don't see this screen. I'm looking at the chat screen. Question number 1, answer 4. Question number 2. Oops. Sorry. You guys have to excuse me a little today. I was a little nervous because this Suji was playing so crazily. She has lost my, she has done 2 mistakes. She has forgotten to turn on laptop, so that I just turn it on. And then again, she has misplaced this paper. That's why I was being little late today. Okay, sorry for that. So that's 6 inert and 5 these gaseous. So question number 1, answer 4. Question number 2, highest bond energy that we know usually it's supposed to go to nitrogen, and they have given that group 15 triple bond makes only by nitrogen, not by phosphorus. So this is definitely answer 3. Question number 3, same shape. If you go with A has a pyramidal shape or bipyramidal shape, and B, water H3O plus hydronium ion has that, and also only E, pyramidal shape. This is a pyramidal shape, all these 3. And this is CIF3 tetrahedral, and BCl3 trigonal planar. Question number 3, answer 3. Acidic strength is asking, I'm going with the answer. D doesn't have any acidity. These are alkenes, no acidity. Moving on to C, this has terminal alkyne, so the evidence is it is releasing H plus with sodium, but it doesn't have any oxygen, so the acidity is less. Then A and B. A is just normal alcohol. This is cyclic alcohol, but this doesn't have this aromatic stability. But B is phenol. Phenol, S percentage is greater here. And the other thing, once you make this phenoxide ion, it is delocalizing within the ring easily, so that formed conjugate base is stable, so that highest basicity is going to phenol. Question number 4, answer 2. Question number 5. Solution of sodium sulfate prepared by dissolving, they were given the milligram values. Sodium sulfate, volume is 500, they're asking the concentration. So we have to, concentration again asking with milligrams per cubic decimeter. But when we are comparing something, whatever the given unit, we have to convert that unit to moles per cubic decimeter. Then only we can compare this stoichiometry, so that the given value is the milligram value. So that multiply with 10 to the power minus 3 to convert into gram. That divided by the molar mass of sodium sulfate gives the number of moles. Now we have some number of moles of sodium sulfate. 1:2 ratio when it is dissociating, it is giving 2 sodium plus. So that the sodium plus moles is 2 into 10 to the power minus 3, that is twice of sodium sulfate. That is the number of moles. Hello? Hello? Okay. Again, I need a little minute. Okay, then we have to convert this number of moles to concentration, so that the volume given is 500 cubic centimeters, so divide. So that is 4 into 10 to the power minus 3. But ppm is milligrams per cubic decimeter again. We have to multiply with the sodium molar mass and 10 to the power minus 3 to convert this grams into milligram. So the answer, question number 5, answer 4. Question number 6. Decreasing order of the volume percentage, whatever the percentage, argon, carbon dioxide, hydrogen, and nitrogen is answer D. And this is the percentages and also traces and also variable traces. Question number 6, answer 2. Question number 7, most rapidly with Lucas. So that comes with more stable carbocation. So let's find more stable carbocation. Out of this is primary. This is actually primary, see. To be allyl, this double bonded carbon is supposed to join to the carbocation, but carbocation become this one. So that's again not accepting. So this is secondary, only tertiary. But here it has this allyl plus tertiary together. So allyl is this. This is the allyl part. Question number 7, answer 1. Question number 8, mass percentage given, density given, concentration is asking, molarity means concentration. See how we see these questions, older questions. In 1 cubic centimeter, mass is 1.24, but concentration is taking in cubic decimeter, multiply with 1000 to go to this cubic decimeter, that is 1240 grams. But out of that, mass of this compound is 20%. So 20% become 248 grams. That grams divided by molar mass gives number of moles. But still they are asking sodium sulfate molarity. If you go with sodium thiosulfate 5H2O2, sodium thiosulfate, stoichiometric ratio is 1:1. So that 1 mole of sodium thiosulfate is existing. But that's in 1 cubic decimeter, so that's become the concentration. Question number 8, answer 1. 9, not true regarding transition elements in general. Remember that they are asking not exactly always 100%, but in general. Read the question being alert. They are all metals. Yeah, definitely all are metals. They form complex cations. Yeah, almost all of them form, other than that ferrospheric manganese with ammonia. They have catalytic properties. I have given some examples. They show variable oxidation states, except scandium and zinc. Except scandium and zinc. But still, this is as a general statement, this is true. Which not true is they do not form oxoanions. See, they are making lots of oxoanions. Question number 9, answer 3. 10. Which of the following electronic configurations corresponds to the atom with the largest atomic radius? That, let's check the given groups. 2 mean, when you are going with this number gives always the period. So 2 means second period, 3 means third period. Largest atomic radius, always going down the group, it is increasing. So I'm going to the third period, but from left to right, it's decreasing. So I have to go with left one. Fourth period, third period, they were given, this is group 14, S2P2. This is group 2. So this is group 17. So the most left one is magnesium. The given compound actually is a magnesium, group 2, third period. Question number 10, answer 3. Question number 11, answer 5. 12, this is a carboxylic acid, so very easily starting number 1 from that. Then go with this longest chain. Question number 12, answer 5. Sinhala and Tara, you don't have this paper with you. You don't have the paper with you, the printed one I've given. You didn't come to sit paper. Just request before leaving. So when you're doing the next time, you have the paper, okay? You need it, like you need to make this pile of these papers and you can use continuously. Okay, increasing order of first ionization energy, you can go with this zigzag. Then see, and also try to memorize these two for second period and for third period separately. So they were just asking here the second period one. Question number 13, answer 1. Question number 14, they have this electron distributed in all these 1, 2, 3, 4, 5 energy levels. How many different wavelengths mean? How many different transitions are possible? But they are asking only emitted, that is going from higher to lower. If you go one by one, you can do different methods. If you go one by one, going always going down, okay? 5 to 4, 4 to 3, 3 to 2, and 2 to 1. 4, 3, 2, 1. Then 5 to 4 is here. Then the rest of them are 5 to 3, 5 to 2, and 5 to 1. Okay. Then 4 to 3 is here. Then 4 to 2, 4 to 1. 3 to 2 is here. Then 3 to 1. 2 to 1 is already here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Question number 14, answer 4. Question number 15. Molar masses of X and Y given the ratio 2:3. So I'm going to get that molar masses as real molar masses as 2m and 3m. Mole fraction is 1:3. 1/3 the mole fraction of Y. X is 1/3. X is 1/3. Y is 2/3. If you cancel off 3, then the ratio becomes 1:2. This is the mole ratio. And this is the molar masses. Mole multiply molar mass is the mass. So that we can get mass ratio 2m/6m. Get the simplest ratio 1:4. So the molar fraction, mass fraction of X become 1/4. Multiply 100, 25%. Question number 15, answer 2. Senara, are you okay? And this explanation, with this explanation, are you understanding everything? Dhoni, Tara, you understanding everything? Let me know if I'm like going too speedy or you're not understanding anything, okay? Question number 16. The way I'm saving time, save your time, save your future. Still, if you feel like not working well, if you are doing silliness of going through this path, just think how lucky you are. You are not me. If you are still not working enough, think how lucky you are. Okay, this is the hydrogen peroxide. Not true statement is asking. H2O2 disproportionate, yeah. In acidic medium, this is a reaction that's also possible. And this reaction is also, we already done, oxidizing to O2. So -1 to 0. H2O2 has antiseptic. That's, you have maybe your own experience. Dipole moment is not 0. To be 0, if this goes like this, plain, linear, through this axis, it's symmetric. It's so that it's 0, but it's not. It has this 3D kind of structure, book kind of a structure. Only these 2 bonds in one plane, or one of these hydrogen and 2 oxygen in one plane. Then the other one is on the other plane. Question number 16, answer 5. Question number 17, sodium boro, whatever the compound, diutheride, borodeuteride. Deuterated sodium borohydride is easier. This is we are not using anymore. Anyway, sodium borohydride, hydride hydrogen joining to carbonyl carbon. Water hydrogen joining to carbonyl oxygen. That you're supposed to remember. Only reaction can occur with the CHO. Question number 11, answer 1. Sorry, 17, answer 1. Question number 18. Salt X heated with sulfuric. It has given a gas. That gas gives a precipitate with lead acetate. Sulfides releasing H2S. Chloride, no gas, it is HCl fume. Nitrate with dill acids releasing NO2. Carbonates, CO2. Sulfides, SO2. So that it's possible to have this precipitates with lead sulfide. Here you don't see gas. This NO2 gas does not release, does not give this precipitate with lead. Lead carbonate is some sort of a possibility is there. So SO3 2- gives this sulfur dioxide with Pb2+, that is lead sulfide, white precipitate. When exhaust heated with dill H2SO and zinc, it evolved a gas that gave a Lux precipitate with lead acetate solution. If you get this lead carbonate, that is, you cannot do anything with that, just existing as it is. But if you have sulfide, reaction with zinc mean zinc is always acting as good reducing agent. Anyway, you have the zinc metal. So zinc has to oxidize to zinc 2+. Then the other species is supposed to reduce. So this sulfide is reducing to hydrogen sulfide. Then again, when you add lead, that gives the black precipitate. Question number 18, answer 5. Ionic radius. All these are isoelectronic, all these have 10 electrons. So positive, smaller, negative, larger. Question number 19, answer 3. This delta H values are asking. Strong acid, strong base supposed to be always -57. Nitrates, what is the given one? Oh yes, darling, no gas here. That's my mistake. I need the answer. Nitrates, no gas. Nitrites releasing gas. True. This working with Suji is, she's really innocent, but always giving me headaches. I don't know where she left my pencil. Yeah, that's true. Just write, make that there is no gas here. I was just misleading. This is like nitrite. This is nitrate, so no gas. We can just neglect that. Okay, thanks for reminding. So if it is strong acid, strong base, they were given 0.1, then I get this idea, it's not 0.1, let's say that's just 1. If it is 1, they are releasing 57 for strong acid, strong base. So strong acid, strong base, 57. But I'm going with from here to I'm going here. This is 0.1 and this is 0.05. So they are still making 1 mole because this is half of this 0.01. So they are again making 1 mole of water, but still the thing is, this is making this precipitation. So the highest is for delta H4, this one, and then the second highest is for the first one, delta H1, then other two. This is one of these members are stronger, but next one both are weaker. So that's supposed to have the lowest releasing energy, 20, answer 5. Suji, 21. Answer 4, who's not participating, not connected to atomic model. Answer 4. Linus Pauling, he introduced this electron negativity scale. Carbocation increasing stability, going with the answer C. This is allyl. If you compare A and also benzene, both are same. Only difference is this is joining with ring deactivator. So it is dragging electrons away. So it decreases the stability. So that lower stability is going to, so that's C, then A. But here you have 3 benzyl systems. So highest resonance stability goes here. So B, 22, answer 2. 23. Gas phase or whatsoever, sodium is most active, very easily you can release electron that has the strongest reducing. If you go through this electrochemical series or whatsoever, it's easy. 24, FeBr3, if it is reacting with FeBr3, so the possible reaction is this, that Fe3 plus is converting to Fe2 plus. So this is reduction. The other one supposed to go through oxidation. +4, +6 possible. No redox carbon dioxide. Cannot oxidize further. There are redox, cannot oxidize further. This is going from -6 to -2 to +6 possible. Chlorine 0 to +7 possible. Question number 24. Answer 3. 25. Not true regarding electrolysis. Chemical energy is converting to electrical energy, not by the electrolysis, but by electrochemical cell. Electrolysis means you are using energy, electric energy. Oxidation state of at least one element of the chemical species is changed in each electrode. Yeah. Must participate electrons. One is oxidizing, other is reducing. pH of the solution changes if water is a reactant only in one. If water in both sides, then one is oxidizing, one is reducing. So same amount of H plus and OH minus are using. But if only one is using this water, one electrode is using water, the other side, let's say H plus is releasing as a H2 in cathode, then OH minus is remaining in the medium, so that medium is basic and so on. The amount of substance produced during the electrolysis depends on the electrical current path, part of this Faraday's constants, this Faraday constant, Faraday first law. Electrolysis is convenient method to produce some, these very, very active metal, top metals of electrochemical series, we use this pure salt, usually the chlorides to produce metal. So part 3 that we said, both supposed to participate for electrolysis of water, anode and cathode. See the anode reaction. During the anode reaction, OH minus is remaining. Cathode reaction, anode reaction, H plus is remaining, so that it has to be balanced. So both supposed to happen, both supposed to produce this O2 and H2 to use the same amount of H plus and OH minus to keep the pH constant. Question number 25, so that answer 1. 26. Not release ammonia with aqueous sodium hydroxide. Okay, I can give you guys these explanations, but you can get this answer very easily. Very, very easily you can get the answer. You don't want any of this. So this is the urea reaction releasing ammonia. Ammonium carbonate, any ammonium source with any strong base releasing ammonia. When even fourth one, this complex is there by dissociating this complex, NH4 plus, there is possibility of releasing ammonia. And number 3 is the identification test of nitrite. When you have nitrite in the medium, with dividers alloy or any other normal amphoteric metal, nitrates releasing ammonia. But this given one, if you check that, the answer, it is using iron powder. They were given both these. So very easily you can get the answer. You can skip all these 3. So iron is not amphoteric, so that it cannot release ammonia from nitrates. 26 answer 5. 27. Bromination. So that is electrophilic substitution. Reaction increases with ring activator. This part is the ring activator side. So to this benzene, whatever the groups are joining first, they were not given anything to join both. And since this is orthopara director, so this is supposed to be joined onto this bromine. So that question number 27, answer 4. Distinguish between sodium carbonate and sodium bicarbonate. If you get 0.1 m sodium carbonate, I ask you guys to remember these values for equilibrium, that's around pH 11. Sodium bicarbonate 0.1, pH 9.6, let's say 9.5. But here concentration are unknown to get these pH values. We can use phenolphthalein. Phenolphthalein only gives the color change only for sodium carbonate, not with sodium bicarbonate. Methyl orange. Methyl orange gives its color change at acidic condition. So both are basic, so not possible. Litmus, both are basic blue. And lime water, both makes the reaction. Sodium carbonate, first converting to sodium bicarbonate when you're adding extra calcium carbonate. And sodium bicarbonate also possible make this sodium bicarbonate also possible to make this sodium carbonate. So that Both are giving this white precipitates, the calcium carbonate. Whatever the reason, they have taken 28. Even like you cannot say this is giving this phenolphthalein is possible because you don't know the concentrations, you don't know their pH. Yeah, this is really little weird. If you go the answer only with A, actually A, that is also not given. Whatever the reason, they were given the answer as all. 29. This question, this equilibrium constant is 10 to the power 25. So this doesn't have this equilibrium. 25 mean very high value. To exist equilibrium, the equilibrium constant is supposed to be in 10 to the power minus 3 to 10 to the power plus 3, plus 25 very high. So we are just going with normal calculation. Equilibrium constant is really high, consider as a straight reaction. I did this for theory as well. So that get the CV of aluminium 3 plus, CV of F minus. We need to find the limiting factor. Aluminium to fluoride 1:6. If we multiply aluminium with 6, 15 into 10 to the power minus 4. But we have 25 into 10 to the power minus 4, that is enough. So that you can see clearly that aluminium is the limited factor. If you check that, we have 25 into 10 to the power minus 4. If you divide by 6, 4.1 into 10 to the power minus 3. But we have only 2.5. So aluminium is not enough. So aluminium is the limited factor. With respect to aluminium, I'm going to find out how much aluminium fluoride is making. So here 2.5 into 10 to the power minus 4, 1:1. Same 2.5 into 10 to the power minus 4 aluminium. So they were taking 25 and 25. So this is the number of moles, 2.5 into 10 to the power minus 4. Divide by 25 plus 25, 50 is the concentration. Question number 29, answer 2. Question number 30. H3PO2. So the oxidation number of phosphorus is +1. +1 can oxidize to +5. So the other one's supposed to be reduced. So A is correct. Only one hydrogen joined into oxygen so that it is monobasic. That's again true. Oxidation number is +1. A, B, D correct. 30, answer 4. (31) when I was even doing this during the classified, students getting confused. Here, the very first thing, they are talking the reaction with hydrogen cyanide with this carbonyl part. And this is the mechanism that Cn minus attacks onto carbonyl carbon. So the reaction type is nucleophilic addition. How you increase the reaction rate? When carbon has more and more plus condition, when it is lack of electrons, very easily nucleophile can join. So when electron density of carbon is less, nucleophilic addition reaction rate is high. So that the highest reaction rate is supposed to come onto this group joining, which is more ring deactivating. So if you go with these 4, I'll go with the answer. So OH providing electrons. So it is decreasing the C plus nature, or it is increasing electron density, but we have to consider one which is decreasing the electron density. So this is the strongest, less strong. But anyway, these are having the slower speed or less speed because these both are ring activators. These two are ring deactivators, and the strongest deactivator is NO2, so that it is dragging electrons away more easily, so that coming and attacking with this nucleophile become easier when electron density is less. 31, answer 2. Not true regarding this hydrides of group 17. HF has the highest boiling point. HI has the lowest bond energy. Yeah, going down the group radius is larger. So that it is releasing H plus to the medium so strongly. So it is the strongest acid. HCl has the lowest boiling point. That's again true. HCl is always the lowest. You have to remember these two are different, and you have to remember these variations, okay? All these three separately you have to remember, okay? You have to memorize. Okay. This is how electronegativity is changing. Fluorine has the highest electronegativity. Iodine has the lowest electronegativity. So that electronegativity difference of HF is the greatest. So that it cannot have the highest covalent property. So that we cannot say HF has the most covalent nature. 32, answer 4. Zinc and copper, they were given that E0 values. We know already this is the galvanic cell. So minus value anox oxidation, red cat reduction. Anode, zinc, cathode, copper. This is the cell notation. And if you add these two together, you can cancel off electrons. So that this is the cell reaction. Copper cathode minus zinc anode. Electromotive force become 1.1 volt. If you separately dig this zinc rod in copper 2 plus and copper rod in zinc 2 plus, you are making this own little cell within this. So that these cell reactions occur independently in both cells. So you cannot make current here. So EMF difference, why? The concentrations of solutions were different. So EMF depend on the concentration. Temperature, cell reaction is exothermic. When the temperature decreasing, cell E0 value is increasing. Corrosion, not the surface area, but let's say some other chemicals can be produced or something, whatever the reason. Not sure about 3. The potentiometer can have errors too. Zinc, the zinc rod and the copper rod were immersed in copper 2 plus and zinc 2 plus solutions respectively. If you done that, you never get this different separate current through the system. So that is something that we cannot accept. Question number 33, answer 4. Compound A reacts with sodium carbonate, releasing a gas, sodium carbonate. All these are possible. You have this quaternary ammonium source. Only one can omit. Turns lime water milky, that's also possible because it's releasing carbon dioxide. A is insoluble in sodium hydroxide, aqueous. Okay, that is a little controversial, but this is the base and these are acids. So this is not actually that good question because ammonium chloride has HCl. That HCl can also react with sodium hydroxide too, but they were taken like that. Just get the extra little knowledge that you can get. Red dye. So these two are only remaining. Red dye with nitrous. Let's say that we can draw this one like this. That CH3 is remaining. This can become NH2 plus HCl. But if you go this one, this is making NH2 CH3, actually NHCH3 and HCl getting away. So this doesn't have this free NH2 to convert this into diazonium. And red dye making with diazonium, that's because you have this NH2 directly joining to benzene ring. Question number 34, answer, but I don't recommend this little thinking this is wrong. For this question anyway, question number 34, answer 5. CV of HCl given. CV of HCl given so that we can calculate number of moles. CV of sodium hydroxide given so that we can calculate number of moles of sodium hydroxide. Temperature change you can get easily going from 25 to 29.5. So that the temperature difference is 4.5. And specific heat capacity, they were given in joules per Celsius per gram. So I'm going to keep this as Celsius, not convert into Kelvin. Heat capacity of the flour, the enthalpy of neutralization of HCl and sodium hydroxide in kilojoules per mole is asking for this given condition, they were using 50 HCl and 100 sodium hydroxide. For dilute solutions, we consider density as density of water. So that 150 milliliter has 150 grams mass. Then heat change equals MC delta T. So we can go with 150 multiply 4.2 multiply 4.5. And if you convert this into kilojoule, that is 2.83. Neutralization enthalpy, same with respect to HCl or with respect to sodium hydroxide, that's for 0.05. Then per mole, we have to divide this by 0.05 to get per mole, 56.7. So they were given the answer as 57. Question number 35, answer 3. 36, directly asking nylon 66. 36, answer 5. Condensation polymer, thermoplastic polymer. 2-butanol reacts with acidic sodium dichromate. This is 2-butanol. Sodium dichromate, see this secondary carbocation converting to ketone. Then another sample of 2-butanol reacting with PCl3, convert OH to Cl, that's B. This is A and this is B. To that adding magnesium triether convert into Grignard. Grignard plus carbonyl. This carbon is joining with the given carbon. This carbon of C joining with this carbonyl carbon of A. 37, answer 4. 38, I was keep given all these resonance hybrids. In nature, all these compounds exist as resonance hybrid. So the closest one to the nature is resonance hybrid. If they were not given that, you have to stick to this correct Lewis structure. Since they were given resonance hybrid, go with that. And this is the only instance that they were given answer as the resonance hybrid. They were never done that after this. Question number 38, answer 2. 39, lowest solubility of hexane. It is non-polar, something polar, and having hydrogen bonding, more polar, is ethanol. 39, answer 3. To dissolve, their polarity is supposed to be matched. 40. Iron Fe3 plus. This is the KSP. Okay, when the temperature is constant, when one is decreasing, the other one is supposed to be increased. pH of the solution increasing by 1 unit. Or pH increases mean OH minus is increasing. When OH minus is increasing, Fe3 plus supposed to be decreased. We have only two answers, 1 and 2. But if you decrease 10 times here, but you have here 10 to the power 3. So that this is decreasing by power of 3. And let's say pH is increasing from 1 to 2. H plus concentration is decreasing from 10 to the power 1 to 10 to the power minus 2. 10 to the power minus 1 to 10 to the power minus 2, that is 10 times. So that this is supposed to be 10 times to the power 3 increasement. So this is supposed to be decreasing by 10 to the power 3 times. So that question number 40, answer 1. Regarding water, what is true? Water reacts more readily with ethanol chloride than with chloroethane. Chloroethane is a normal alkyl halide, no reactions with water, and this is water insoluble. This reaction is faster. So this is the reaction with water, any acid halide. Water reacts rapidly, this Grignard, yeah. Water acting as a proton donor. But what is producing? This is just a proton donor. This one breaks from here. CH3 joined with hydrogen to produce CH4. So it's not a methanol, that's wrong. Dipole moment of water is not 0. See, this has dipole moment through this oxygen to this direction. C is not correct. In ice, they are making 4 hydrogen bonds. That's true. Question number 41. A, D correct. Answer 4. 42. Produce acidic solutions and dissolve in water. Strong acid, yes. Chlorate, strong acid, yes. Strong base, basic, no. Out of these two, consider HF as weak acid. So not even neutral, this is again basic. 42, A, B, correct, answer 1. 43. This is again, you have the knowledge of equimolar mixture or non-equimolar mixtures that we went through both. If it is equimolar, we can compare XA and XB and also XA with YA, XB with YB and also YA with YB. We cannot compare this way if it is non-equimolar. And boiling point of A is greater mean volatility of B is high. So that the volatility of B is high, so that B goes more to the vapor phase. So that in liquid phase, A is greater. Liquid phase, A is greater. In vapor phase, B is greater. Anyway, whatever it is, in one phase, we have only two components. So if you add these two molar fractions together, it's supposed to equal to 1. So that XA plus XB equals to 1. YA plus YB also equals to 1. Initially, XA equals XB because it's equimolar, but not once it reaches equilibrium, since XA plus XB equals to 1. YA plus YB equals to 1. So these two supposed to be same. In gas phase, B more volatile, Y is greater. Question number 43, B, D correct, answer 5. 44, wrong regarding graphite. It's not sp3, it's sp2. Melting point is extremely high. It has this sp2 hybridization. One free electron is delocalizing within the ring, this making this poor pi bonding. So through that, they can pass electricity. No use in fuel. Graphite, we never talk about graphite using as fuel. So not as a fuel. Question number 44. A, D, incorrect, not true. Just see who got the answer as 3. Not true, A, D, incorrect, answer 4. 45. Steam distillation, true statements asking. Is used to obtain ethanol after fermentation of sugar. Ethanol water, this is miscible, so we cannot separate with steam distillation. We are using the Raoult's law. That's supposed to be fractional distillation. Steam distillation of clove given as essential oil that contain ethanol as a major constituent. True. Composition of distillation remain the same during steam distillation of, they evaporate independently. Whatever the part going to vapor phase is independent. Whatever the part remaining is independent. So that the ratio is not changing, so that the composition is not changing, because both are going same way. Petroleum refineries, we are again using the fractional distillation. All these compounds are miscible. So as a fraction and fraction, we separate really in petroleum industry, all these different components. True statements asking. 45, BC correct, answer 2. 46, true about metals. They conduct electricity. All the metals do that. Not always their density is greater than water, because lithium, sodium, potassium float on water, less dense. But they react with dill acids, not always. That's depending on the position of the electrochemical series. Elements above hydrogen do that, but element below hydrogen, they do not release H2 with dill acids. Only 22 nonmetals in the periodic table. Majority of elements in the periodic table are metals. True statement asking 46. AD correct. Answer 4. 47. Tara, were you feeling your marks are increasing when you are doing these papers? It is a must, Sinhala. 47. So you are in which level now? You are in which level? 30s or 40s? Have you gone to? Yeah. Out of 60, what is it? Out of 50, definitely is supposed to come, everybody's supposed to come above 42, okay? It's a must. Let's go, and then I'll support you. You guys have to have this communication, like just get my instructions with your condition. When I'm giving instructions here, I'm giving this commonly to everybody. Which of the following statements are true about homogeneous chemical reaction system of dynamic equilibrium? Homogeneous, that's roused, dynamic. Rate constants, you cannot say that equal. If it is equilibrium system, both forward backward rates are equal, not constant. See, they are trying to trap you here. That's why I want you guys to save time. When you are saving time, you can think slowly. Concentration of all components, yeah, all macroscopic properties, concentration, number of moles, pressure, temperature, volume, mole fractions, all are constant. Macroscopic properties are changing. Le Chatelet principle is using to predict changes, yeah. Increase in temperature will increase the rate of both forward and reverse reactions. True. Only if endothermic, wrong. Both for endo exo, that's why it's wrong. 47, BC correct answer, 2. 48. Do I need the explanation? No, just write these oxidation numbers. Answer 5, BD, only BD, not redox. Oxidation numbers not changing. 48, answer 5, BD correct. 49, stereoisomerism is there. You have this chiral and cis trans both. It reacts with aqueous HCl. Mixture two alcohols which show position isomerism. Yeah, minor product and major product. Since it's aqueous, so since it has also OH in the medium, joining of OH is also possible. When subjected to catalytic hydrogenation, so this is become CH2 here. It gives haloalkane, which does not show stereoisomerism, wrong, but still you have this chiral carbon. Sodium fusion test is out of syllabus, just don't worry about this. 49, only A, B correct, answer 1. What is the answer, Tara? Lori? Sanara? Answer? 49? Your answer? 1. Come on. 50. True. Ideal gas. Distribution of molecular speed depends on temperature. Temperature, kinetic energy, mean scale speed. Constant pressure means Charles' law. The rate of change in volume with respect to temperature is independent of the temperature scale. Yeah, even it is constant or not. Whatever these changes occur without the scale of this centigrade or Kelvin. That's true. Volume of the sample of is constant as long as the temperature. Not only the temperature, but has to think about the pressure as well. Pressure of the gas depends on not the square power, just the number of collisions, not the square value, number of collisions per unit area. Question number 50, only A, B correct, answer 1. HF is a weaker acid, yes, than HCl in aqueous solutions. Bond length is less, hydrogen bond is there, anyway it's true. Fluorine is more electronegative than chlorine. That's not the reason. Reason is supposed to come through this. 51, answer 2. Addition of few drops of H2SO4 to water increase electrical conductivity so dramatically. H plus has the highest ionic speed. Oh, okay. Fluorine is more, H2SO4 increases the dissociation of water molecule. That's wrong. Okay, this is the dissociation of water. Whenever you are adding any H plus to the medium, this is increasing. To decrease that, reaction is going to backward. So its dissociation is decreasing. But H plus coming from acid is acting here. 52, answer 3. Yeah, is it? I got it. I didn't check it. I'll renew during the break, okay? Okay. Question number 53. Polyvinyl chloride. That is PVC comes with this chlorine. This is poly. Poly mean this polymer. So that doesn't have double bonds. It's not unsaturated. It is saturated. So it's wrong. Polyvinyl chloride is made by this. That's true. That is unsaturated, not this polymer. So that question number 53, answer 4. Question number 54. All the nucleophilic addition reactions. In the nucleophilic addition reactions, aliphatic aldehydes are generally more reactive than aliphatic ketones. If you go with this nucleophilic addition reactions, so this carbon supposed to have more and more plus charge. 1R group, it is decreasing, but with 2R groups, it's decreasing more because through the inductive effects providing electrons. So the first statement is sort of true. Electron release from the alkyl groups in the ketone makes the carbonyl carbon less positively charged. Generally, this sounds like correct. Whatever the reason, they were not explaining about electron release mean electron is providing or it's partial or whatever the reason. With this some sort of a technical issue, they were given answer as all. Anyway, 54 answer all. 55. An oxidation reaction and a reduction reaction always occur simultaneously. Yeah, it is a must. One is given electron. Only if one is given electron, the other one can take up electrons. All chemical reactions are not even disproportionate. All chemical reactions are not even redox reactions. There are normal reactions, there are normal like displacement reactions always occur without any redox. So this second statement is so wrong. 55, answer 3. 56, change of H plus. pH of the solution changing from 1:2, same as 3:4, wrong. This is correct. pH we're gonna get it like this. As an example, going from 1 to 2, concentration changes from 0.1 to 0.01. Difference is 0.05. 3 means 0.001. 4 means 0.0001. And that is this difference. So difference is not. Units are same, but the concentration difference are different. Memorize these as facts so that you can save time in our real exam. So that question number 56, answer 4. 57, this is aliphatic amine. You have CH2NH2, but this is aromatic. This is aniline. Soluble in aqueous HCl, but amide is insoluble in aqueous HCl. Even this is aromatic, but still they have this. This has more basicity, but this is less basic compared to this compound. But still, they both acting as bases, so that basicity is enough to react with HCl. But in amides, this CO bond is dragging this lone pair towards itself, going here. So that basicity is less to react with HCl. So first statement correct. Basic strength is the other way around. Basicity of amines are greater, very greater than amides. Second statement wrong. 57, answer 3. 58, wet litmus paper. Maybe we can use, maybe we cannot use, because both are acidic. So both are turning litmus to red. So cannot mean yes. Both are acidic gases. That's the reason. That's why both are giving the red color. So that answer is 1. But there is another property of SO2. It can decolorize even the litmus papers. So for SO2, it's not remaining in red, but that red is diminishing with time so that we can distinguish. So that first statement becomes wrong. So that answer is 4. Then you guys are not asking me questions, but these some students are asking me this question. Sometimes they are giving this answer, either this is correct or then the either same thing is incorrect. Then how do we think about our real exam? Okay, my solution is in real exam, then they were never given such questions again. Confusing questions, they are not given again, but then they were making another mistakes in some other places. So it's totally different. That's why there are a couple of answers, so don't worry. 59. Real gas deviate from ideal behavior at high pressure and low temperature. Yeah. A real gas molecule has a smaller volume than the ideal gas. Real gas volume is larger. Okay. Real gases, when at high temperature, when we increase temperature or when we decrease pressure, both these condition volume is increasing, and also when we increase temperature, kinetic energy increasing, so intermolecular interactions are decreasing. And also with the decreasement of pressure, since the volume is increasing, molecules get apart from each other, so that they don't get this chance of making these intermolecular interactions. For all those reasons, high temperature, low pressure, getting more closer to ideality. So this is given the opposite of that, so that it's correct. This is incorrect. 59, answer 3. Thanks, darling. 60, the ionic product of water Kw. Dissociation water is endothermic. So that if you heat it, increasing temperature has to increase the dissociation so that Kw is increasing. Dissociation is endothermic, not exothermic. 60, answer 5. Okay, now I need the moment of truth. These wrong answers, just get whatever the way you want your marks. I don't want you to lose your confidence level. Making these marks are really low. You can write to the group, or you can. Dilu, you were in the waiting room. Wow, good. Very good. Impressive. Hurry up. Ramudi, I love you. Tara, darling. Tony. Wow. Wow, Dilo, impressive. Okay. So the highest is 53. That's for Ramudi. That's really, really good. But all are above 40. That is really, really promising. Yeah. Harumini 47, Deepna 41, Purna 49, Moindu 41, Nimri 42. So even they were in this higher level in final exam, this is their marks for this paper. So you guys are in exactly this challenging nature. And all these students who were requesting, who would request recording, I want you guys to give me all these, your marks, previous marks as well. I am really, really happy with even this 29 marks is sort of not that good, but for you that we can be happier because we are improving and you came during the last minute to me, and just trust yourself. When you guys are with me, I have this power, some sort of a power I have that I can improve you guys. So just go steadily with me. I know I can do this. So trust me that you can do this. Only thing is just stick to the plan, whatever the plan we decided to go through, stick to the plan and you can do this. And again, a little, see their determined faces. I was saying the marks of these 5 students. Even Deepna's marks are not that good. Yeah, it's 51. That's all right then. Yeah. We have 2 more papers doing with 60 questions. I want you everybody to touch 50. Okay, even 50, that's more than enough. But 40, like the getting closer to 50 is really, really enough because these papers are like all syllabus. Some stuff are even I'm not comfortable. I know you are not comfortable. Okay, together, I'm just reminding this again. I want to make sure once you're done with this paper, do this self-review. Are you guys doing the self-review? And then you guys are improving that self part before the next paper. That is a must. That's how all these students to reach this highest successness. What I'm expecting from you, I want you guys to reach above island 29, either island 28. Yeah, so I'm reminding again, this is how you're supposed to go. Once we're done with structured essay and essay everything, you are going through this paper right now after, like you can do here or you can go home and do that. If you are staying at home right after we finish everything, going through everything, MCQ, structured essay and essay, analyze yourself and think yourself, what could I do to reach 100 marks? How many mistakes I have done during these, not only to these MCQs, you are doing it to structured essay and essay as well. Only that part, only that part you are improving before the next paper. Don't get stressed. Let's say that you have 10 points to remember. That you have 10 points to remember for whatever the question we do. Do you have 10 points to remember? Whatever the question we do, we only want this third point, but you don't remember any of this. Don't try to memorize everything right now. Forget this part, forget this part. For 2009 paper, you only improving this the third step, third point. If you go through everything within this little time of period, you would feel very, very stressed. Trust me that you are improving, and I'm improving you guys. And I left 1 extra week, 1 or 2 extra weeks. We have little extra timing. We are in really, really good shapes. Be happy and trust yourself. All the students are still struggling to cover these syllabus, and some are still they don't know, they don't have any idea how to do a full paper. They are doing these model papers. They never done that exam full paper, leaving 2 hours and 3 hours getting this experience. So you guys are in really good shape. And the other thing, just feed this to yourself. You don't want 100 marks to get a good A pass and to go to your dream university and dream faculty. 100 is the challenge. Just reach your goal, then try to exceed that. Your goal is to go to this, whatever these good faculties in Sri Lanka. So that is your goal. Once you reach there, you can exceed that, targeting 100 marks. Don't get stressed. We can do this. Let's say that your physics is poor, or maybe your biology is poor, so or maybe your maths. That's really all right. Not all these students are going to do these engineering and medical faculties getting these 300 marks, 100 for all these three. Okay, so analyze this paper, improve this paper, just to make sure when you do this second time that you are getting 100 marks for this paper. That is the target only from this paper. Okay, so we are moving back to time is 10. We can do a little extra before moving on to this break. Structured essay part. Again, before that, before moving on, I'm not showing the answer, otherwise you're not concentrating. If you are coming to me, I would give you instructions. Next week, next Monday is the open day. Next Monday, hang on. For Ratnapura students, I'll write separately. Here I'm talking about Colombo students because Monday is the Colombo day. For Colombo students, next Monday become your open day to sit for the exam. Then I can interact with you. I can give you all these instructions. And I hope this is the general normal Monday because you are coming regularly to my classes. Get here to get this experience. Otherwise, just bring me and to get these instructions if you are doing at home. If you would not be able to come on next Monday, you can collect paper before that. Not this week. I'm coming again next Friday. Then Friday to whatever the date, up to Tuesday, I'm staying here. So you can, maybe you can send somebody, your parents or your driver or somebody to bring the paper. I don't have it today, otherwise I would give. If you are not coming on a Monday, you can bring this MCQ, that sheet if you want. MCQ sheet, you want that answering sheet. Okay, that is this, again, we are going with this squeezing timing. We are squeezing timing. And the other thing, be really, really happy with your marks because you guys are struggling with timing. Senara, did you go with the timing like first paper 1.5 hours? Okay, so I'm happy with everybody. I'm happy all the students who were with me other than that Hasandu who came later. I'm really happy and proud. You guys are so much better. Have this confidence. I totally forgot that I didn't give you guys 2 hours. I just gave 1.5 hours. So within 1.5 hours, this is really, really good. And since I went from the beginning to these 22 students, in their 2009 paper, they had 2 hours. So whatever their marks that I said that Harumini 47, Deepna 41, Purna 49, all those marks, that's for 2 hours, not for 1.5 hours. So you guys are doing great then. Be really happy and proud. I'm so happy for you guys. Seriously, I'm happy. So even this time we can expect district rankings, or maybe island ranking. I don't know whether you guys are lucky, but I'm lucky to have you. I'm lucky to have you. Okay. Atomic mass unit, we are not using this atomic mass unit anymore. We are using unified atomic mass scale. Unified atomic mass scale. Everything's supposed to be here. You're going to get 10 marks. If you lose one single thing, it's 0. After 2019, up to 2020, 2019, I was keep saying this. They were not asking anything directly from the theory. But after 2019, since they made so hard, they worked so hard to make these resource books. Now they are adding little stuff to resource books, so we can expect definitions. 1/12 of exact mass of chemically unbound carbon-612 atom is the unified atomic mass scale. Just write that, unified atomic mass scale. It's not atomic mass unit for our new syllabus. Then I am moving on to the Sinhala one for rest of these parts, because the Sinhala one I made all these better explanations because I did the Sinhala one first in this one. And see, unified atomic mass unit value 1 U or 1 Dalton or 1 atm equals 1.660454 into 10 power minus 4. They were not given marks for this, but for your practice, it is there. Part B. Okay. So they have AF2 minus and AF4 minus. So A comes to the middle. 2 fluorine. Fluorine never gets minus charges, so I'm just assigning the lone pairs. These days I'm doing, Sinhala, I'm doing this. I'm done with Lewis and I'm done with Vesper. Do you want these recordings? These recordings are free. New students who are with me, not when we are doing these unit lessons, you can request recordings. I can send it. This week I'm doing hybridization. So you can just fast forward, whatever the part comes, you can just listen that part. Okay. Request a recording if you want to. For 2025, I'm done, Luis and Vesper. Coming this tomorrow, not tomorrow, no, on Wednesday, I'm doing this hybridization. Then, to complete the octet, I need to assign 3 lone pairs. Going to AF4 minus A, 4 fluorine around that, 1, 3, and 4. Just scratch, okay? Then no negative charges on fluorine, so I'm assigning all these 3 lone pairs for each. Then around A, only 4 electrons, 1, 2, 3, 4. To have 8 electrons, I need to give another, to complete an octet, I need to give another 2 lone pairs. Negative charge supposed to come on to A. Okay, so 8 minus 7 is minus 1. So that the group number is supposed to be 17. So it's group 17. They were given marks 15 here and 15 here. Just writing group 17, 10 marks. And then here, to balance this equation, this is completed charges or the atomic number. And this side, it is 6. So 2 plus 6 is supposed to be equal to 6 plus 0. So this is 0. Charge is 0. And then this is supposed to be atomic number 0 mean this is supposed to be neutron. The charge is 0. This is supposed to be a neutron. So that neutron, the mass is 1. So 12 plus 1. 12 plus 1 supposed to equals to 4 plus x. So 13 minus 4 equals to 9. So this is 9 and 4. And then they are asking to identify x and y. X you can write either alpha 2,4 or helium 2,4. Y is the neutron. Okay, this question. Okay, they were saying one of these elements is a metal. What do you know about metallic elements? These are consecutive. One is a metal. Metal is supposed to be coming from the lower period. But here one is very, very low. So these are sort of like getting closer to increasement. But out of these, the lowest one is very, very low. That is 495. So then they are consecutive. If the metal is in group 1, this is again a metal, this is increasement, and then this is again a metal. So that these are getting very closer. Then the metal is supposed to come in from the next period. So that this variation is supposed to come from here to here. So you have two variations, either this one or this one, increasing and decreasing. So then this is supposed to be the metal. If this is the metal, other variation is supposed to go from neon, fluorine, oxygen, and nitrogen. Then the next, the lowest one, the largest one supposed to be go to neon, that is Z plus 3. Then the next largest is for fluorine, 1681. Then oxygen is the least, that is Z plus 1, 1313. Then nitrogen is supposed to be that the larger than oxygen, that is 1402. Are you guys understanding me? Okay, then the answer comes like this. See, the lowest one, the largest one, next larger, and the next larger is supposed to go on to nitrogen. The next smallest one is going to oxygen. I'm just asking, stick to the path, just go together with me each week. And it's really promising that this path for these previous students, that's why I'm just asking, because sometimes you would feel new students are sort of okay, they just follow everything. But all students, they are thinking, we are done with chemistry, now we have the better knowledge with chemistry, so we can just suspend the chemistry little, we can go with other two. Then they are falling behind. Don't let this happen. Never lose the grip of chemistry. Okay, here just you can go on. CH2NO2. CH2NO2. Then they say on heating, 2 moles of ammonia is releasing, and only nitrogen containing product is ammonia. So releasing 2 ammonia means there are supposed to be 2 NH4 plus. If I get these 2 nitrogen from ammonia, so you have to multiply this by 2 to get 2 nitrogen. So this multiplied by 2, then molecular formula becomes C2H4N2O4. And also from this one, if you release 2 NH4 plus, or if you go with 2 ammonia, this is become H2C2O4, or 2 NH4 plus become C2O4. That NH4 twice, so plus charges into 2. So this is supposed to have minus 2, that is definitely then oxalate. So the name become ammonium oxalate, 10 marks. Ammonium oxalate, 10 marks. Formation enthalpy of carbon dioxide is asking, so that we have to insert that the word CO2. CO2 is coming with carbon and O2, so we have to insert all those terms. The enthalpy associated with formation of 1 mole of CO2 gas at standard state from naturally occurring carbon solid graphite and O2 gas at standard state. Whatever the given condition, now we have inserted CO2 gas, carbon solid graphite, O2 gas. That is the only thing. Moving on to part B. Okay. So, going to this unit 1 to unit 5, we did like long ago. You may have forgotten these theory and these calculation parts. So the concentrate well. Total mass of graphite is 72 grams. Okay, that we know we have 72 grams. Burning, it is giving all these three. Carbon monoxide, carbon dioxide, and also unburned carbon is also remaining. If you know the percentages of these two, that you can get the percentage of carbon, that 100 minus 28 minus 66, that is 6. Okay. So those are the mass ratios. A standard enthalpy of formation of carbon monoxide and carbon dioxide also given. First, they want us to calculate mole ratios. So multiply each by its molar masses. I have written here molar masses. Divide each by the molar masses. Mass divided by mole mass is number of moles. 0.1, 0.5, 0.5, 1.5. So multiply by 2. So that the mole ratio become 1:2, 2:3. So doing this calculation, 3 marks. For this answer, again, 3 marks. And total moles of carbon monoxide release is asking. Total moles of graphite, total mass is 72 grams. If you divide by 12, we can get the total moles of graphite. That is 6 moles. Out of that 6 moles, 1:2, 2:6, 3 ratio mean all these together again 6. 2/6 is carbon monoxide. Out of these 6 moles, 2/6 is carbon monoxide. So number of moles of carbon monoxide truly made is 2 moles. Understood? 1:2:3. Yeah. So you are not getting full marks if you only write the final answer. No. There are always alternative methods. They are again dividing marks for those. Yeah. I'll show the marking scheme once we done this. I have and you have that here too. If you want, in the meantime, if you have enough time that rather than listening that you can watch, go with the marking scheme now, or otherwise in the recording, I have also added the marking scheme. So you can check that because some students are requesting marking schemes. Part B, where is this part? Okay, next part, number of carbon dioxide. So the carbon dioxide fraction is, ratio is 3/6. So the fraction is 3 divided by 6. But we have all together 6 moles. So that's 3 moles. Tara, your answers are correct. Very good, darling. Okay. Then number of the heat release on burning 1 mole of graphite. Okay. So this 6 moles of carbon gives 1 mole of carbon, 2 moles of carbon monoxide, and 3 moles of carbon dioxide. Okay, this heat release only by this carbon monoxide and carbon dioxide, to the theory, they were to the as a data, they were given that per mole value here. Per mole value for carbon monoxide is 111. Per mole value for carbon dioxide is minus 394. Let's try to find how much it is releasing from this given number of moles. Okay. So for 6 moles, it is this. Per mole, we have to divide all these by 6. Per mole, it is making 1/6 carbon, 2/6 carbon monoxide, and 3/6 carbon dioxide. Then delta H theta carbon monoxide equals 2/6. So that 111, how to multiply by 2 divided by 6, that is minus 37. And then for carbon dioxide, minus 394 has to multiply with 3/6, that is minus 97. So together, releasing energy is this. And see, they are asking released on burning. So the numerical value is 234 kilojoules. And here they say, this is again a little controversial, they were just changing this. But memorize this one. If they are asking releasing energy, that's already negative. So you are not writing negative value here. Releasing energy, you are just writing it is releasing 234 kilojoules. Okay. Then they want us to show, to deduce whether this reaction, a conversion of the CO and CO2 is exothermic or endothermic. They were given these formation enthalpies so that we can go as state functions. This is the carbon monoxide to carbon dioxide. So that product is carbon dioxide minus 394. Reactant is carbon monoxide minus 111. And go always with unit C. They were always giving like 2 plus 2, numerical value plus unit. Here again 1 plus 3. That is 3 mean 4, sorry, 1 plus 5. 5 4 answer 1 4 unit. So that value is minus 283 kilojoules per mole. Even if you want, you can go with the thermochemical cycle as well. Next question is again very easy. An industrially important organic compound X contain CHO. They want us to write this balance equation. I'm not explaining. You guys know how to write this balance equation. And just to remove this y/2 and this is y/2 as well, I have multiplied this whole equation by 2. Okay, so that they are giving marks for both. It doesn't matter that you need to multiply. Just I did that to make it more easier for this explanation. Then they are giving a little again a hard time. They were not talking about grams. This time they were talking about milligrams. Milligram of this hydrocarbon, milligram carbon dioxide, and milligram this water. Then ratio become 2:2. 4x plus y plus 2z divided by 2 is 2. Carbon dioxide 2x is 2 water. Y. Since they were given milligrams, multiply by 10 to the power minus 3 to convert into gram. Then divide by each of these molar masses. So you can get this ratio 1:2, 2:3, which is supposed to equal to this given ratio. So 2:2, 2x supposed to be equals to 1:2. So that you can find x. Then again, 2x is to y. Supposed to be equals to 2:3. So that knowing x, you can get y. Then 2x plus H6 hydrogen plus OZ equals to 62. Then 62 minus 24 plus 6 is 30 equals 32. Then divide by 16. 2 oxygen is here. So Z equals to, so that 2. This is correct and they are giving fully marks and I have mentioned it here. See, I have mentioned it here. Okay. Then next part they say with sodium it is reacting 62 milligrams. 2 milligrams of H2 gas is releasing. Okay. The ratio again multiply by 10 to the power minus 3. Divide by the molar mass, we already know that they were given. And 2 is the number of moles of H2. Divide by the molar mass of H2 is 2. Then 1x release 1H2. Okay, to relieve 1x from 1H2 molecule from 1H, there are supposed to be 2 OH groups. There are supposed to be 2 OH groups. So that these 2 oxygen, that Z equals to 2. These 2 oxygen supposed to come from 2 OH groups. So either this is correct or this is correct. They are asking different intermolecular interactions in these molecules. Ethanol, see they were given names, you need formula C2H5OH, methanoic, HCOOH, propane, CH2CH2CH3. Ethanol has hydrogen bonds. They are asking the main one, you don't have to write London forces secondarily. Methanoic acid again hydrogen bonds. Propane has only London forces. 4 marks for each. Increasing order of boiling points, methanoic acid is the greatest because its London force strength, its hydrogen bond strength is greater because it has 2 oxygen. Then just normal hydrogen bonds ethanol, least for propane. I'm trying to find this explain. Okay, explanation. Propane, dipole moment equals to 0. You have to write this part, okay? You can start from non-polar. You're going to start from this. In this new modern chemistry, they are giving separate marks for this part. So it's non-polar, only London forces. These are weaker intermolecular interactions, so that lowers boiling point. Ethanol consists direct OH bonds, consists strong hydrogen bonds, but since number of oxygen is less, hydrogen bonds and hydrogen bond strength is less. More stronger hydrogen bonds with COOH group shows highest boiling point. This one, you're supposed to assign these lone pairs onto this oxygen. They were not asking anything about this oxygen and these they were not asking, otherwise you're supposed to assign lone pairs on all these oxygens. Anyway, so 4 bonds around sp3, 1, 2 lone pair, 4 pairs sp3, 1, 2, 3 sp2, and this carbon 1, 2, we are not getting this pi bonding for hybridization, so it's sp2. This is optically active, so I'm going to go with chiral carbon. 1 carbon, hydrogen, 1 carbon, 2 carbon, then reacting 2,4-DNP and not reacting with silver nitrate. So this is not aldehyde, this is a ketone. So this rest of the part I'm going to draw as 1, 2. If I join this oxygen here, that's become the aldehyde. That is wrong. It cannot be an aldehyde. It's supposed to be a ketone. So double bond oxygen gets here. 16 marks. So this is the answer. Okay, moving on to question number 4. 4 reactions are here. First reaction is Friedel-Crafts acylation. It is Friedel-Crafts acylation. Friedel-Crafts acylation. Suji! This is the product. Then adding green art to that CH3 group joining onto this carbon. Suji, mage pencil ek poda metana hoyala diyana hemi. Ara potas eda balana. So that here they are not adding water here. Not adding water, so that it's supposed to stay like this. Or MgPr. Once you add water, this is breaking. And O minus Mg plus is also necessary. So this is the B. Add water, this bond breaks and hydrogen joins, and this is the product. And this is, okay, this one, if you forget this part, let's say that dil H2SO4, it doesn't do anything with this one. So that the only possibility we can go with may be dehydration. So this is the product. They can confuse you. And the reaction type is asking. Okay, this is the reaction with benzene. They are just not given as electrophilic or nucleophilic. They are just given these for, now they are asking, in modern chemistry they are asking. Anyway, so the first one is CH3CO plus is the electrophile. Benzene characteristic reaction is electrophilic substitution. They were asking S, so it's SEOS. Okay, then the next one is this double bond breaks. This double bond breaks. The nucleophile attacks onto this carbon. So nucleophilic double bond breaks addition. So nucleophilic addition go through my organic short note. It's a must. I don't ask, I command you. It's a must to go through my organic short note. Okay, then the next one is this MTBR gets away hydrogen joins. So one gets away, another joins. So that is a substitution. From the given condition, just think. We never done this. But one group gets away, another group joins. So substitution. And this is definitely elimination. And this is electrophile and this is nucleophile. You can use only these reagents. And it is showing from this single compound, you are making 2 different compounds. Joining them, you are making this. This is an amide. One side is carboxylic acid. The other side is the amine. So one side you are making the amine. Other side they were given the carboxylic acid. But this is joining here, not the initial carboxylic acid. So that the next step is supposed to be that other than carboxylic acid, if you make this carboxylic acid to acid halide, reaction is really fast and effective. So that this is acid halide. Okay, so the first step is converting this PCl5, adding PCl5 to convert carboxylic acid to acid halide. Then this part is done. Then the next part is to convert this acid halide into 2 carbon amine. Okay, we don't want this double bond. 2 carbon amine. First, we need to join this NH2 here. If you remove this CO part, joining of NH2 is harder. So I'm just leaving this as it is. Addition of conc ammonia, making this amide, lithium aluminium hydride ether, then water, you are making amine. Add these two together, you are making this amide. How easy these questions? I'm going to show you guys some pictures. This 2024 students celebrated May, what is this? Teachers Day with me. This surprise, this, you know, the cakes and balloons and little stuff. Okay. Next one again. You want to get here and you have from benzene containing something and these two positions to each other para. So first we're supposed to join a para compound, and usually not always, usually ester part supposed to come at the end. So before that we have to convert this into COOH. So before this I can think of this. Then coming here, from here starting one. Okay, making this is really easy. They were given only 2 compounds, nitrobenzene and toluene. Did you try the nitrobenzene part? Nitrobenzene part, if you try nitrobenzene, then actually that's also possible. Who started from nitrobenzene? Even if you started nitrobenzene, that's also possible. If you connect nitrobenzene, then you can convert it to NH2, then you can go with Friedel-Crafts alkylation. That's also possible, okay? This is also possible. Addition of CH3, then nitration, then convert NO2 group to NH2, then CH3 to COOH, then esterification. Both methods are possible, but you can stop these 2 steps. Even if you had conc-HCl here, they were not given marks because you guys know that Cl minus react with potassium permanganate. That we did in organic chemistry analytical part. NH2, why can't you swap these 2? What happens if you swap these 2? First adding H plus KMnO4, then convert into COOH. Yeah, COOH react with this sodium hydroxide, and that's again getting this confusion. So you can swap these 2. And this part also correct. If you have gone here, first NO2, then this step, then here you are adding CH3Cl, AlCl3. That's also possible. Then going through the oxidation. See, I have written it here. In the pencil, I have written it here if you've done that. Is that all? Is that all structured essay? Wow. See? I know you guys are amazing. I am amazing, I guess. I make you guys are this talented. Discussing everything, writing, showing, teaching everything, it took 45 minutes. Just writing this, can't you do this within 45 minutes? Yes, you can do this. Get this improvement. When they were talking to these, all these students, when they were talking to these other students in front of the class, I'm bringing them in Ratnapura, it's easier because they live in Ratnapura. They will keep saying, doing 2-hour paper to 1 hour and 30 minutes, then time never became the challenge. They were never having issues with timing. Okay, shall we go to the break then start essay part? Okay, let's take that time as, yeah, exactly 10:44. Let's say 10:45, in my one 10:45. 10 minutes already, darling. Do you guys want 15 minutes or 10 minutes? Donnie? Donnie? Okay, I'll be back around then 10:55. I'll be back around 10:55. That's funny. Last time her face was like kind of funeral. Kind of face. You okay with it, darling? Actually, everybody's taking it in this time because they are just saying one way that you can just read it. That is very obvious. But I'm very happy that your mom is so I don't need to worry about it. Anyways. Question number 5. Moving on to the essay part. Check the timing. Very soon you can finish this. Why is that? That's because these questions are really, really easy. This is just like you are just drawing a diagram. If you know the diagram, let's say you are just drawing Atapatiya Malak, you know the diagram, it takes very little time. That is my target. Just give you everything before the exam, then it's just nothing for the exam. Challenging. Okay, initial number of moles of X is 2. Temperature is 450 constant. At this equilibrium, they say 25% of initial X is decomposing, so you can find the dissociated amount. Total pressure is given. This ain't you feel like when you are reading this question, answer is right at the, how is these answers? Okay, so they are first asking these molar fractions, then the Kp. So initially 2, then 25% is dissociating out of the initial, but initial is 2. So that 25% out of 2, which equals 0.5. So that reacted amount becomes 0.5. So that remaining become initial 2, reacted 0.5, 2 minus 0.5, 1:2. So that if this is X, this is supposed to be 2X, 0.5 into 2, that is 1. So get the total number of moles, 2.5. Divide each by total number of moles, molar fraction equals 3/5, 2/5. Multiply each with the total pressure to get the partial pressures. These are the partial pressures. Since they were not asking partial pressures, I'm not simplifying this because I know I can cancel off this when you are dividing 1 by 1. So square value mean you are writing this twice. Then a px, write the Kp expression. They were given a couple of marks for that as well. Do the simplification. Kp equals 1.6 into 10 to the power 5 Pascal. Then initial temperature was 450. Now it is increasing to 600. Then there is another equilibrium starting. Y is dissociating to Z. They are still using same initial X. Finally, they found in the mixture 1 mole of X, 0.5 moles of Z. Remaining amount is 1. Then stoichiometric ratio between X and Y is 1:2. So that from this 1, I'm using the same color, you are making 2Y, 2 moles of Y. But out of that, 0.5 Z is making from Y. Then Y:Z ratio again is 2:1. 0.5 supposed to make by dissociating twice of Y. So that dissociated Y amount become 1. So that remaining Y become 2 minus 1. That is 1. So this is the answer for part A. Amount of Y remaining is 1. Understood? Okay. So rest of the part is easier. 2 minus 1, 1, 1, 0.5. Total number of moles become 2.5. Then divide each by, get the molar fractions. So then they are asking this for the part B. Then part C, total pressure, number of moles are volume constant. Pressure depends on temperature. So first pressure, first temperature is supposed to equal to second pressure, second temperature. So that the pressure equals 8 into 10 to the power 5 Pascal. Then D, equilibrium constant is asking for that. We need new X and new Y partial pressures. X and Y. See, X and Y still the same. To save time, I'm just going to go with partial pressure of X equals partial pressure of Y. Molar fraction into total pressure. Knowing that, writing the Kp expression, just do the substitution. Answer is 3.2 into 10 to the power 5 Pascal. How easy. If you have any assumptions, this is the way I have shown this remaining y equals to 1. Assumptions. All above gases behave ideally. Volume of the container does not change with the temperature. If you want to go for 100 marks, 100 out of 100 for chemistry, just memorize these assumptions. Then thermodynamically, 450, at 450 it's 1.6, you can cancel off 10 to the power 5. 600, 3.2. When temperature increasing, Kp increases mean forward reaction supposed to be absorb energy. So the forward reaction is supposed to be endothermic. Okay, 75 cubic centimeter of aqueous solution, solute E, shaken with 50 of chloroform. Then they say 75% of E was extracted into organic phase. They want to calculate the Kd. How is it? E 75, chloroform 50, and out of that, to chloroform layer 75% extracting. Let's say the initial amount is X, so the remaining become 25% of X. Okay, then this is the two different whatever the amounts, but still we have to divide by volume because these two volumes are different. Equals to Kd, that I get a chloroform to the top. So that equals 9/2 or 4.5. Unreactive liquids. They are given the Tx and Ty boiling points. Initially, they were using equimolar. Equimolar means 0.5. Mole ratio in vapor phase. Then you boil it. You heat it. Starts to boil at 2. Then make the parallel line to x-axis until you touch this. This is a gas curve or vapor curve. Then you are coming down to get the new composition. So this is mole fraction of y. So then y is 0.75, it's supposed to be 0.25. Clear that? So that x is 0.25, y is 0.75, x is to y equals 1:3. Separation. Distill the mixture and collect distillate. Since y is more volatile, composition of y in distillate is high. Repeat the same process and condense the distillate until composition of y becomes maximum. Continue until distillate contains only y. Or otherwise, you can use this, the staircase, this diagram to explain whatever the way they were given marks. We did lots of these kind of questions. So the first part is asking about the titration 1. Strong acid HCl, strong base sodium hydroxide. Concentration is also considerably high. Acid concentration is given initially. To this acid concentration, moving on to Sinhala 1. Okay. HCl in the mixture, so that pH is supposed to be very, very low, and 1:1 ratio. So addition of sodium hydroxide, see, this is again 25. They were adding initially 25 cubic centimeter of sodium hydroxide. So this is the drastic pH. Then they were gone up to 50 cubic centimeter of sodium hydroxide. So the medium is really basic now. They want us to explain all these A, B, C points. If you go with A is yes. But there are other questions in these newer papers. They were using this one part is weaker. Then you have to use all these equilibrium laws. This is the equation 0.3 into 25 to 10 power minus 3, but here 12.5, so that you can calculate number of moles. Obviously, HCl is greater. Get the difference to get excess HCl. This is the total number of moles of HCl, but still total volume become 25 plus 12.5. So that is 37.5 into 10 power minus 3. So that is 0.1 moles per cubic decimeter. Minus log 10, I'm adding this little part. I'm not sure whether they're going to use that. Just to show that units are cancelling off, that pH doesn't have unit. So pH of A is 1. That is point A. Point B, you can just say this. I have calculated NHCl equal N sodium hydroxide, CV, total or complete neutralization, so that pH equals to 7. Point C mean, I'm getting together. Now you have sodium hydroxide, that is 50, get the CV of sodium hydroxide. Then this is a CV of HCl. If you divide by total volume is 50 plus 25, that is 75. Okay, that is 0.1. Get the minus log 10, so that this is sodium hydroxide concentration. Here you are calculating POH from this, because this is sodium hydroxide. POH equals to 1. Sometimes you do this little mistake. Don't let this happen. 14 minus 1, so that pH equals to 13. But they were not mentioning this temperature equals to 25. Then in this table, they wanted us to show for other 3 conditions, whether this is increasing or decreasing. Okay. If you go with the second one, what happened is, only difference is same strong acid, same strong base. Go with your question. Rita? 0.03 acid, 0.03 base. මේ දෙන්නට ගෙනත් දෙන්න අර ඊයේ ඉතුරු වෙච්චි 2009 එකේ papers දෙකකුයි අර answering sheet එක ඒක දෙකකුයි. Okay, so initially pH supposed to be high because acidity is less. So then pH is going high, increasing. Clear that? Because the H plus concentration is now low. 25, it is exactly 7, so it's not changing. This one after 50, now sodium hydroxide concentration is also less. So that pH is supposed to be less than earlier. So this is decreasing. Clear the first one. Then third one, sodium hydroxide part is still the same. So this part cannot be changed. Because once you neutralize, you are adding sodium hydroxide. That's a strong acid. It is controlling the pH. So pH remains the same, unchanged. නෑ ඔච්චර ලොකු සෙට් එකක් එපා කොහොමද දෙන්න ඕනේ මේකයි විතරයි හොර ආන්සරින් ෂීට් එක අර ප්‍රශ්න 60 ලියන එක ඒක ඔක විතරයි දෙන්න ඕනේ ඔය දෙක දුන්නාම ඇති එකයි මේකයි නෑ මේ දෙකයි ඔය දෙක එක්කෙන්ට දෙන්න ඕකේ මේක සෙට් එකක් අනිත් එක්කනට දෙන්න හරිනේ හරි okay then moving on to the third one now the acid is weaker so that pH supposed to be because acid is weaker H plus concentration is less so that pH supposed to be increasing so you are titrating with sodium hydroxide so at neutral time you are making this sodium acetate sodium is strong base so that it's increasing and this is not changing I already said that and the last one that's again acidic so it is greater then pH is again less this is again increasing that you can understand easily this one last one now sodium hydroxide concentration is 0.1 it is less than 0.3 so that H plus OH minus is less so that pH is less clear that OH minus is less OH minus high pH high that question is not in English okay part B initial concentration of ClO2 pH given initial rate given so we can find everything but we need this data directly given this data directly given for this ClO2 but this is not given we have to find OH minus concentration from the given pH okay to derive this order we need the rate expression I'm just going to go with this kind of rate expression since I have introduced this M and N I could and also K and I am showing them here then pH plus POH equals 14 POH equals so that 2 then we can find the OH minus concentration for pH 12 equals to 0.01 then the other one pH equals to 13 so POH equals to 1 that one concentration of OH minus is 0.1 so now we have all the data we need so using this 3 different R values were given whenever you are doing this you have to go with units otherwise no marks for this part then each of these ClO2 concentration and each of these OH minus concentration. If you go with first and second one, that you can cancel off this. You can find M equals to 2. If you go with 2 and 3, these two equal, you can cancel off. These two are different. So N equals to 1. Increasement of temperature by 10 degrees Celsius. Reaction rate increases For theory, we learned this when the temperature increases by 10 degrees Celsius, usually reaction rate doubles. So you can write that part as maybe it can be double. Order and temperature, there is no connection. Does not change. Mechanisms does not change with temperature. They are saying that as a fact. They are saying mechanism does not change when you increase the temperature. So that with that we can say order does not change. I have that here again and again. Question number 7. Silver nitrate sodium bromide mixing. Show that precipitation occur. We're going to show that calculating this Cl plus concentration and Br minus concentration separately. Ionic product is greater than Ksp. Calculate the mass of dry precipitate as well. Given that all these data, okay? Okay. So they were given Cv of silver nitrate and sodium bromide. So this is the silver nitrate Cv. So that becomes the Cl plus concentration. 1 silver nitrate gives 1 Cl plus. And the total volume equals to 25 plus 75, that is 100, dividing by total volume. So we can get Cl plus concentration. Same way, you can find the Br minus concentration, sodium bromide Cv, divide by the total volume, you get the Br minus concentration. Get the ionic product by multiplying these two. And silver bromide Ksp 10 to the power minus 13, ionic product is 10 to the power minus 6, very high. So silver bromide get precipitated. Okay, now Cl plus concentration is 1 is to 10 to the power minus 3. Br minus concentration is 6 into 10 to the power minus 3. But here the ratio is 1 is to 1 is to 1. So that this becomes the limited factor. So same amount of silver bromide coming to the is making. But this is moles per cubic decimeter. See, all these concentrations are moles per cubic decimeter. But here, out of that, they were only using 100 cubic centimeter. In that mixture, in 100 cubic centimeter, only remain number of moles is 1 into 10 to the power minus 3. That multiplied with the molar mass is the mass. Silver bromide precipitate is 0.080188 grams. Zero point 166 grams of silver chromate dissolved in 50 cubic centimeter of water at room temperature. Then you have 50 cubic centimeter of water. This is a mixture. To this you are adding sodium chloride solution. Cv of sodium chloride is also given. 2 into 10 to the power minus 5, 50 cubic centimeter of that. These changes were happening. The reddish brown precipitate dissolved and a white precipitate formed. So reddish brown precipitate mean when you add water, so this is dissolving but not fully dissolved. So you are leaving some sort of a silver chromate not dissolving, then that you know all the other chromates are yellow but silver chromate are red. So this silver chromate is a red brown precipitate. We're going to show that the dissolved amount is greater than the molar volume, so that the excess amount is precipitating. Then they say white precipitate is formed. So that is when you add sodium chloride. Now white precipitate means that silver chloride is making. So we're going to show that silver chloride ionic product is greater, so it is precipitating silver chloride. so that this is getting dissolving. And the color of supernatant solution become distinctly yellow. That's because this silver chromate is now releasing to the supernatant, because CrO4 minus is now free. Silver is reacting with chlorine, CrO4 minus is free, it is going to supernatant, so that this is red-brown precipitate form already dissolved to give this yellow color to the supernatant. Okay, I'm taking all these steps separately. Formation of red-brown precipitate. Mass of silver chromate 0.166. Divided by the molar mass is the number of moles. That number of moles divided by the volume is the concentration, 0.01 moles per cubic decimeter. But as a data, they were given this. Molar concentration, molar solubility. Molar solubility of silver chromate is 8.4 into 10 to the power minus 5, mean if we add more moles to this solution, it is getting precipitated. But here we have calculated this molar concentration is 0.01, way greater than 8.4 into 10 to the power minus 4. So that the rest of the part is getting precipitated. Since use amount is way greater than this, silver chromate get precipitated. Initially, red-brown precipitate is formed. Okay, that white precipitate is silver chloride. I'm going to show that. This is the sodium chloride added. Convert into moles by multiplying 10 to the power minus 3 to cancel off decimeters. But in the mixture, now we have sodium chloride and silver chromate as well. So that the total volume here is 100 divided by 100. So that this is the initial Cl minus concentration. What is the initial silver plus concentration? Now, silver plus concentration supposed to be coming from this molar concentration of silver chromate. This is the molar concentration of silver chromate. But silver chromate, each one has 2 silver plus. So that silver plus concentration become molar concentration multiplied 2. Regardless, 0.01 silver chromate supposed to be in the medium. Since this is partially soluble, majority of this part is precipitating. Only in the aqueous medium at equilibrium condition can remain only this amount. Clear that? Okay, so this is the silver plus and Cl minus. Multiply these two. See, AgCl, the ionic product become this. And this is the AgCl KSP. This is less. This is less. So, ionic product is greater. So that a white precipitate is forming. Why this is getting dissolved? Now, this is not enough to complete its molar concentration. Once you make silver chloride, now silver is using and staying with chloride. Now, silver is not enough to make this silver chromate. How are you going to show that? Dissolution of red-brown precipitate, dissolution of silver chromate. Minimum silver plus aqueous to precipitate silver chloride. To get precipitate silver chloride coming from AgCl, KSP and Cl minus. This is a KSP expression. So KSP AgCl is silver plus plus Cl minus. If you subject silver plus from this, you can find the silver plus KSP given. Cl minus we already calculated, that is 1.8 into 10 to the power minus 5. Let's see, this is in the medium. So this is the silver plus now in the medium. Let's see, with this silver plus, how much CrO4 minus supposed to be in the medium to precipitate silver chromate. So this is the silver chromate KSP. How much chromate is supposed to be in the medium now with this new concentration of Silla plus? So chromate subject, KSV Silla chromate divided by Silla 2 plus. So that is 7.4 into 10 power minus 3. But that is per cubic decimeter. But we have only 100 cubic centimeter. And in the given solution that we already calculated, in the given solution, we have 5 into 10 to the power minus 4. That is the total CrO for 2 minus concentration. Silla chromate to CrO for 2 minus 1 is to 1. Same number of moles of CrO for 2 minus is in the medium. But to satisfy this KSP, to get this precipitate, chromate supposed to be in the medium, supposed to be 7.4 into 10 to the power minus 3. But that's not enough. We have only 5 into 10 to the power minus 3. Clear that? This is the initial amount, but again, that's even diluting. Even diluting. 100 cubic centimeter, it is 5 into 10 to the power minus 3. So that 7.4 needed, but we have only 5. That's not enough. Since chromate is less than 7.4 into 10 to the power minus 3, which needs to precipitate Silla chromate, it does not form a precipitate. How this supernatant become yellow? Since chromate get dissolved, supernatant become yellow, which is the characteristic color of CrO42. I'm so glad that you came with marks. Okay, here I'm not showing marks. Here I'm not showing marks because this is more clear. I got this from my classified. I just copy paste. See, when I'm doing classified, I'm doing everything really nicely. Same as when I'm doing full papers, this is a huge mess now. But it is here, so you can see how they have given marks. This one, part B. That corrosion is out of syllabus, but electrochemistry is in syllabus. So see, this is really not clear. This is a iron electrode, nitrogen ion electrode with it has oxygen. So whatever this oxidizing part is, let's see, how did I get with that? The oxidation, that's reduction. I just need to get this point to explain. Yeah, here in nitrogen medium, this is inert. So then there is no oxygen for reaction, so that this is getting oxidized. Since you're adding O2 here, I mean the air here, so that air is going through this reduction, iron is going through the reduction. Let me explain that. Bubbling of nitrogen is an inactive gas, so it is coming with then less oxygen concentration, so that here iron oxidizes. That is the anode. Bubbling of normal gas, so O2 concentration here now, so that O2 is reducing, so that is the cathode. So that in anode, supposed to be oxidation, only thing you have is iron, so iron get oxidized, so this is the anode. Cathode, you have oxygen, that oxygen is reducing to OH minus here from 0 to minus 4. That is the cathode. Rest of the old part, so that is then easier. Anode, cathode, balance equations for anode reaction and for cathode reaction. Then total complete reaction. How to identify? Fe2 plus we can identify with potassium ferricyanide, Prussian blue precipitate. OH minus with phenolphthalein, it is giving this pink color. And this phenomenon we can say ion corrosion or rusting. Are you comfortable with this? Solution Y contain H2SO4 and oxalic acid. They are doing this titration. Balance equation is asking H2SO4 and oxalic concentrations are asking. These equations, you can go with half reactions and you can get these equations. But I want you guys to memorize this for the final exam because you can save timing. Either you can go this balanced ionic equation or the balanced chemical equation, whatever. So potassium permanganate 2, oxalic 5, H plus 16. First one, they are saying titrate with KMnO4. So that volume is 24. So this is the CV of KMnO4 is this. But the stoichiometric ratio is 2:5. So that multiplied by 5 to get oxalic, but still have to divide by 2 because there are 2 MnO4 minus. So that number of moles of oxalic in 25 cubic centimeter of Y equals 3 into 10 to the power minus 3. If you divide 3 into 10 to the power minus 3 by 25 cubic centimeter, you get oxalic concentration. Now we have a little problem here because in this medium, we have separately H plus coming from H2SO4 and also oxalic also has H plus. So this is little complicated. Okay, from this equation, we can again find how much oxalic and how much H plus. From equation number 1, MnO4 minus O, C2O4 2 minus O, H plus can be found only for that reaction. If you take away H plus from H2C2O4, remaining H plus become H plus coming from H2SO4, so that you can find H2SO4 concentration. So that H plus total from H2SO4 equals remaining H plus in the medium after reaction 1, whatever the part is remaining, then part used for equation number 1. But with that, again, you have to subtract how much H plus coming from oxalic. Clear that? Because remaining H plus and H plus coming from this H2SO4 and H plus coming from oxalic, both are reacting. Then one part is remaining, part is using, the other part is for oxalic, the other remaining part is the H plus coming from H2SO4. Then they were given the volume of sodium hydroxide 15, concentration is 0.04. So number of moles of sodium hydroxide spent is this. That is 0.6 into 10 to the power minus 3 or 6 into 10 to the power minus 4. Sodium hydroxide is to H plus equals 1:1. Once the reaction occurs, so that the remaining H plus, That is the remaining H plus this part, which equals a 6 into 10 to the power minus 4. Then from equation number 1, that potassium permanganate is to H plus equals 2 is to 16. Okay. So that potassium permanganate number of moles equals 1.2 into 10 to the power minus 3. To get H plus multiply by 16, since you have 2MnO4 divided by 2, that you can find H plus used for that reaction number 1. So that H plus used for reaction number 1 equals 9.6 into 10 to the power minus 3. But knowing this oxalic concentration that we already calculated, or oxalic number of moles, is 3 into 10 to the power minus 3, but one oxalic is having 2 H pluses. So that NH plus from H2C2O4 equals 3 into 10 to the power minus 3 multiplied 2. That is 6 into 10 to the power minus 3. Twice of oxalic number of moles is number of moles of H plus came from oxalic. Now we have everything for this substitution. So that H plus from H2SO4 equals that remaining 0.6 into 10 to the power minus 3, and then equation number 1, use for equation number 1, that is 9.6 into 10 to the power minus 3, and then H plus came from oxalic. Okay, so just simplify this. You can get number of moles of H plus came from H2SO4 is this. Here again we assume H2SO4 releasing 2 H plus, so that we have to divide by the H plus concentration to get the H2SO4 concentration. Initial volume is 25. Divide by 25, you can get the answer. Who did this question? Are you understanding this now? Listen my recording twice. Bleaching powder we are not doing, but I'm just giving this. It's a little out of syllabus, but calcium carbonate gives calcium oxide. That calcium oxide with water gives calcium hydroxide. That is passing Cl2. This is a bleaching powder. This is truly seriously out of syllabus. And this is part we can get because we are doing this for organic chemistry. From calcium carbonate, you are getting calcium oxide. This reaction we did for organic chemistry. With carbon, it is producing calcium carbide. That calcium carbide reaction with water gives calcium hydroxide plus C2H2. C2H2, this is the organic first member of alkyne group. In 2009, something has happened to the ship. It is sinking with H2SO4. What are the detrimental effects of this leaking of H2SO4? Oh, tragic. Okay, harmful to fauna. Fauna mean animals or fish. And harmful to flora. Flora mean plants. Harmful to corals. Lowering of pH. Since acid dissolution is exothermic, evolution of heat or heat releasing, and evolution of carbon dioxide reacting with calcium carbonate acids. Decreasing dissolution of O2 in water. Any of this you can get. Question number 9. This mixture, I'm going to go with this mixing them separately. Each of these, when you are mixing, same thing, no reaction. I minus with Fe2 plus, this is a reaction. Sorry, Fe3 plus, this is a reaction. In ionometry, we did that. It is releasing I2. So it is giving this pale brown. Actually, not pale brown, this is red brown because that excess Ki is in the medium. Barium chloride, potassium iodide, no reaction, no change. Potassium iodide, potassium ferrocyanide, we never done anything, so no change. Fe2 plus Ki, that I2, red brown. Barium sulfate, white precipitate. And Fe3 plus potassium ferrocyanide, Prussian blue. And again, barium chloride, potassium iodide, no reaction. Sulfate with barium white precipitate. These two, we never done any reaction. Potassium iodide, potassium ferrocyanide, no reaction. Ferrocyanide, no reaction. Fe2 plus potassium ferrocyanide, Prussian blue. And these two are no reaction. Okay, this is the explanation then. Mixed solutions as pairs. Barium chloride and ferric sulfate gives a precipitate. So we can separate barium chloride and ferric sulfate. Then add one of the above two, remaining two. So we have separated this mixture, ferric sulfate and barium chloride. So I'm going to add these two. This one to both these, and then this one to both these. Okay, who gives this blue color? Blue color comes from these two. This is giving the blue color with this one, then this is supposed to be ferric sulfate. Now we know all this one, and this one, so the remaining one is potassium iodide. That's again we can separate. So if we add this identified ferric sulfate to potassium iodide, it is given this red-brown color, I2 films. Say that. This explanation, this handwriting is not clear. That's why I explain. Okay. If we get dissolved, this finely powdered aluminium and zinc in both these get dissolved very easily in sodium hydroxide. Then these two cannot dissolve in ammonium chloride, so that we can separate sodium hydroxide, ammonium chloride. Then add sodium, aluminium, to aluminium and zinc mixture. When you're adding sodium hydroxide, here you are getting precipitate, which is insoluble in excess. Sorry. Both get dissolved and both insoluble in excess. To this mixture, you are adding ammonium chloride. If you add ammonium chloride, this is just existing as precipitate, but ammonia plus zinc giving this ammonium zinc hexaamine complex. So this is getting dissolved, but this is just staying as a precipitate with ammonium chloride. This is not that complicated, little complicated. On heating, this decomposes to give given residue, colorless feed and water. Then that gas reacting with magnesium to give D, and they say to whatever this is magnesium salt, addition of water, it is releasing ammonia. Then this salt is supposed to be nitride. Salt is nitride to release ammonia because they are saying litmus turning, so it's basic. So this is supposed to be magnesium nitride to release ammonia. This is nitride with nitride, with magnesium giving nitride, that is nitrogen. That part can sort separately. That is nitrogen. Then again they are saying this is heating with sodium carbonate. That is a strong base. It is again releasing ammonia. Strong base, ammonia. What is this salt? Salt is supposed to be any sort of ammonium salt. You have to think backward. Ammonium salts with strong base releasing ammonia. So this is ammonium salt releasing nitrogen. And it is releasing any residue, leaving green color residue with thermal treatment, any ammonium salt, only single explanation we know is ammonium dichromate. So that we can start from ammonium dichromate. So all these can be solved then very easily. So that these are the answers. A, ammonium dichromate, B, chromic oxide, C, nitrogen, D, magnesium nitride, E, ammonia. And these are the reactions. 1, 2, 3, 4, 5, 25 marks. Winkler. Okay. Write this question number on the top page of your question sheet or answering sheet. You want to memorize this again because we didn't do this any of these Winkler method calculation for theory when we were in unit 14. But for the exam, they can give this because Winkler method has included to the syllabus after 2019. And you guys are now not new, so they can add whatever it is. In the determination of dissolved oxygen in a sample of water, so 250 water sample, to that they were added manganese sulfate and excess potassium iodide in alkaline medium, so it is producing MnO4. Solution then acidified, then liberated this I2, I minus converted to I2, titrate with CV of sodium thiosulfate given. From this CV, we have to find O2. Write the balanced chemical equation, calculate the concentration of dissolved oxygen in ppm, milligram per cubic decimeter. Okay. These are the reactions. Manganese in alkaline medium oxidized with O2. This is the dissolved O2, and it is making this little complex. That complex reacting with I minus to produce I2. That I2 is reacting with thiosulfate. We know the thiosulfate from that I2, from I2 to this, from this to O2. So if you add the second and third equation, you can get the fourth equation. I didn't write that. You can add these two together. Second and third together gives the fourth. You can cancel off this. I minus, so on. So that if you add that equation, if you multiply that by 2, and when you add equation number 1, then you can cancel off this Mn over all this. See, this is you have 2, this is you have 1. That's how you're going to multiply this by 2. Then you are ending up here. Remember this. You only need this. 4 times of thiosulfate divide 1 times of oxygen is 4 times of thiosulfate. CV given, that value is this 2 into 10 power minus 4. Divide by 4, this is the oxygen concentration, but they were taken 250. So that is the concentration of O2, but they're asking ppm multiplied by 32, multiplied by 10 to the power 3 to convert this into milligram. So ppm milligram per cubic decimeter, 6.4 milligrams per cubic decimeter. What I can do is, I want you to remember this one. I'm gonna send this to the group, 2 groups, I mean. Okay. Question number 10 part B. I have translated everything to English because I don't want to write this twice. Everything is here. Given below the flow chart of the production of sodium carbonate by Solvay process, since we know this is a Solvay process, and starting materials are A, B, C. D, byproducts from the starting material B. Waste material is E. They are giving such information, so it's making they are making it a little easier. And this is heating. These are the raw materials: limestone, ammonia, and seawater. What do we heat? We heat only the limestone. So that this is supposed to be limestone. And then concentration. So getting the seawater, we concentrate it to get this brine water. So that this is supposed to be seawater. And then the other one, this is supposed to be then ammonia. There are swapped these two towers, but you can understand this clearly. Okay, then limestone heating gives calcium oxide. Because calcium oxide we are using separately, and carbon dioxide is the one which is going directly to this tower. So this is tower 1. And then ammonia is supposed to go to this the other tower. Then here, by concentrating this sodium chloride we are introducing. So now we have ammonical sodium chloride. To that, we are adding carbon dioxide. Why we are adding ammonia first? Dissolution of ammonia in water is high, so that we can mix carbon dioxide very easily. Ammonical brine has basic medium. So dissolution of carbon dioxide is here. So that you are making this ammonium bicarbonate, and by filtering we separate, sodium bicarbonate. By filtering we separate sodium bicarbonate, and by heating we are making sodium carbonate. They are giving downward here, you are coming to sodium carbonate. And then this is a byproduct, calcium hydroxide with ammonium chloride. By heating we are again making this ammonia. That ammonia is again introduced into this tower. And these are also the byproducts, calcium carbonate, calcium sulfate, or magnesium sulfate, magnesium chloride, whatsoever. Byproducts coming from remaining part of this brine. Yes, everything explained. Got it. Write the balance equations for F, G, and tower 1. F is this. Ammonium chloride, calcium hydroxide gives ammonia, calcium chloride, water. This actually is the main byproduct here. And ammonia is reusing. And G heating, sodium bicarbonate is decomposed into sodium carbonate. And this tower 1, that ammonia, carbon dioxide giving ammonium bicarbonate, that is reacting with sodium chloride gives sodium bicarbonate. Or we can add these all together just to write production of sodium bicarbonate. This is again one of my, I don't even remember, I'm just getting this. This is the library of, I'm just showing this to show you guys this. It is really, really happy, beautiful life when you're doing your PhD. And I'm just showing the marking scheme. If you need to get something from this, then you guys know, you can just make sure that marking scheme is there. For these papers, I couldn't find this Sinhala marking scheme. See, they were given, Tara, they were given all these alternative methods as well. You can go on. Work well, stick to the path. Never ever give up any of these three, and never ever give up working on me. I just want you to, like, leech just, you know, the sucking blood. Just cling to me, grab me, use me, abuse me whatsoever, I don't care. Misuse me or whatsoever until you finish the exam. Then I don't want even to contact whatsoever, I don't care that. But until you get the exam, really beneficial to stay with me because I'm bringing you guys to this 100 marks. So stick to the path to go for this higher successness. And couple of you are promising, and lots of you are promising that you can reach about this. All right. I'm ending the meeting. Bye. Take care, everybody. With Sarnai.